locus of complex number involving modulus. So we'll go one by one. Z minus Z naught is equal to R, or let's say R. So here it's clearly this represent a circle with center Z naught and radius R. This represent a circle with center Z naught and radius is equal to R. Okay, so let's say Z plus I. This represents center minus I and radius is equal to 4. So radius is 4, not 2. Okay, it's R, not R square. Second, minus Z1 upon Z minus Z2 modulus is equal to K. So we'll see one by one. If K is equal to 0, then it turns out to be Z minus Z1 is equal to 0. So this clearly represents a point. Okay, so basically you can observe that this is something a circle with center Z1 and radius 0. So that means clearly represent a point Z1. What if K is equal to 1? If K is equal to 1, so K is equal to 0, they represent point. For K is equal to 1, line perpendicular to line joining Z1 and Z2. So if K is equal to 1, that clearly means Z minus Z1 is equal to Z minus Z2. So this, suppose this is Z1, this is Z2, this is line joining Z1, Z2, and Z is a line. So this is the locus of Z, which is line perpendicular to Z1 and Z2 and equal distance. Okay, now what if K is less than 0? Obviously it's not possible. If K 0 means modulus, so if I K 0, K less than 0, K less than 0 means Z minus Z1, Z minus Z2 negative. Clearly not possible because modulus cannot be negative. That is, in this case, no locus. K is greater than 0, but K is not equal to 1. That is, K is greater than 0 and K not equal to 1, because K is equal to 1 represent a line. So K greater than 0 and K not is equal to 1, they represent a circle. And what kind of circle? With center K square Z2 minus Z1 upon K square minus 1 and radius. So this is center and radius is K Z1 minus Z2 divided by K square minus 1. 2. So whenever we want to locus, we ensure that the coefficient of Z should be 1. Here the coefficient of Z is 2. So we'll take 2 outside. So it becomes 2 Z minus 3 by 2 upon Z minus I is equal to 2. So Z minus 3 by 2 upon Z minus I modulus is equal to 1. So this basically clearly represent a line joining 3 by 2 and I. So this is something, if you want to see the line, so I is somewhere here and 3 by 2 is somewhere here. Now this is the line joining I and 3 by 2, and our locus is a line perpendicular to this. So this is the locus of Z. Let's say 3. Z minus Z1 plus Z minus Z2 is equal to K. In this case, again based on the K, so let's say if K to mod of Z minus Z1 minus Z2. So if K is Z1 minus Z2, so in this case locus of Z is a line segment. Is a line segment joining Z1 and Z2. So clearly somewhere is Z1, somewhere is Z2. The line segment, the locus is just a line segment. This is the locus of Z. This is the line segment joining Z1 and Z2. Okay, so this is for KZ1. What if the same question, what if K is less than Z1 minus Z2? So obviously in this no locus is possible, no Z is possible, no locus is possible. Okay, clearly why? Because the sum of two sides is less than third side. So why it's not possible? You can see that suppose this is Z, suppose this is Z1, this is Z2, this is Z. So this is Z minus Z2 distance, this is Z1 minus Z2 distance, this is Z minus Z1 distance. So if the case is mod of Z, if the case is Z minus Z1 plus Z minus Z2 to K, which is less than Z1 minus Z2, is not possible, because this is Z minus Z1 plus Z minus Z2, sum of two sides is less than third sides. That clearly is not possible. Okay, now next case is, what if K is greater than Z1 minus Z2? If K is greater than Z1 minus Z2, then this locus is a ellipse with foci Z1 and Z2 and length of major axis, okay, is K. That means if Z minus Z1 plus Z minus Z2 is equal to K, which is greater than Z1 minus Z2, then this clearly represent a ellipse with foci is Z1 Z2 and distance between this length is K. Okay, so locus is a ellipse if K is greater than Z1 minus Z2. Let's take the fourth case. What if Z minus Z1 minus Z minus Z2 is equal to K? Again here this is K, depending on whichever is dominant, the K will be negative. So let's make it modulus, so don't be confused, so that K is positive. Okay, so even though if we don't put this modulus, okay, then you have to see that this K value is negative if Z minus Z2 is greater than Z minus Z1. Okay, what if K is Z1 minus Z2? line. But which kind of line? So is basically Z is a ray. Locus of Z is a, so locus of Z is a ray. So locus of Z is a ray originating or emanating from Z1 and Z2. So I am trying, so this is the Z1, this is Z2, so this is the locus. Okay, this is locus of Z, this is locus of Z. So in case of, in the previous case, see, if there is mod of Z1, mod of Z minus Z1 plus mod of Z minus Z2 is K, they represent the line segment between Z1 and Z2. And in this case, the modulus of Z minus Z1 minus mod of Z minus Z2, in this case, they represent a ray originating from Z1 or Z2, okay, and going away from the Z1, Z2. So this was this case. What if K is greater than mod of Z1 minus Z2? Again here, no. So let's see what is happening here. So this is Z, this is Z1, this is Z minus Z2, this is Z1 minus Z2, this is Z minus Z1. So in this case, we see that mod of Z minus Z1 minus Z minus Z2 is equal to K, which is greater than Z1 minus Z2. What does it mean? It means that the difference of two sides is greater than third side. So that is the triangle with difference of two sides greater than third sides, which is clearly not possible. So no locus, no Z is possible. Okay. Next case, what if K is less than Z1 minus Z2? That means this is Z minus Z1 minus Z minus Z2 is equal to K, which is less than Z1 minus Z2. In this case, the locus is a hyperbola with foci is Z1 and Z2, and K is the length of transverse axis, or in terms of equivalent to ellipse, we can say length of major axis. So something like this. So this is Z1, Z2 is the foci of a hyperbola, and length between this major axis, that is K. Okay, so this is the locus. In this case, K is less than Z1 minus Z2, locus is a hyperbola. So fifth case, if let's say Z minus Z1 square plus Z minus Z2 square is equal to K. If K is greater than Z1 minus Z2 whole square upon 2, then they represent a circle. They represent a circle with center Z1 plus Z2 by 2 and radius something 2K minus Z1 minus Z2 whole square by 2. This is the radius and this is the center. Yeah. So mod of Z plus Z bar plus Z minus Z bar is equal to K. In this case, the locus is a square with center origin. Okay, that means this is something a square, something like this. This is a square, with these are points K by 2 comma 0. This is 0 K by 2. This is minus k by 2 comma 0, this is 0 comma minus k by 2. Okay, so here doesn't matter whatever k may be 1, k may be 2, anything. Achha, what if k is equal to 0? In this case, if k is equal to 0, obviously they just merge to a one single point. Okay, this 0 everywhere here, that's the origin. And if k is, and k can't be negative because this modulus sum of two k can't, because sum of two modulus is always a positive. So k is always positive, and this case locus is a square. Okay, 7th, z minus z1, let's say, upon a z bar plus a bar z plus b is equal to k. See clearly, this denominator in this case is a equation of a straight line. So in this case, they represent the locus is a conic section. Locus is conic section. This is a straight line a z bar plus a bar z plus b0, and this is z1. So obviously this is z. So in this case, z1 is the focus. So in this case, z1 is the focus of conic section, and a z bar plus a bar z plus b is the directrix of a conic section. K into 2a is the eccentricity of conic section. So clearly, if k into 2a is equal to 1, okay, then it's a parabola. If k into 2a is equal to 0, that clearly represents a circle. We know that eccentricity of circle is 0. If k into 2a is greater than 1, then they represent a hyperbola. And if k into 2a is less than 1, then they represent the ellipse. So let's take one example. Let's say z plus z bar is equal to 2 times z minus 1. So clearly we observe that something like this. 2 is equal to mod of z minus 1 upon z plus z bar. So here this is 1 by 2. So clearly k is half and a is 1. So k into 2 modulus of a is nothing but 1. So therefore the locus is a parabola. So clearly, just last revision. So z minus z1 is equal to r. They represent a circle. Z minus z1 upon z minus z1, we write like this, or we can also write like this: z mod of z minus z2 is equal to k. So if k is 0, they represent a circle, or they represent a point circle basically. K is equal to 1, they represent a line, perpendicular line. K greater than 0 and not equal to 1, then they represent a circle. And this is z minus z1 plus z minus z2 is equal to k. We say that k is equal to, if z1 minus z2, they represent a line segment joining Z1 and Z2. They represent a line segment joining Z1 and Z2. K is less than Z1 minus Z2. No locus is possible. K is greater than Z1 minus Z2. It is an ellipse. Okay. Fourth point, if let's say Z minus Z1 minus of Z minus Z2 is equal to K, again here K is equal to Z1 minus Z. In this case the locus is a straight line originating from Z1. It's basically a array, okay, originating from Z1 and Z2. K is less than Z1 minus Z2. It is a hyperbola. And K is greater than Z1 minus Z2. So no locus is possible. Okay. Fifth point is, let's say Z minus Z1 whole square plus Z minus Z2 whole square is equal to K. They represent if we observe that 2K K is greater than Z1 minus Z2 whole square by 2, they represent a circle. K is equal to Z1 minus Z2 square by 2, they represent a point. And K is less than Z1 minus Z2 whole square by 2, they represent no locus is possible. Okay. And let's see sixth one. Z plus Z bar plus Z minus Z bar is equal to K. Basically, it's not a new thing. Z plus Z bar is just a 2x. Okay. In this case, the locus of Z is a square with center at origin. Center of the square is origin. Okay. Next is Z minus Z1 is equal to K times A Z bar Z plus B. So basically in this case we observe that A is a complex, Z bar is also complex, A bar is a complex, Z is a complex, whereas B is a real number. So this is a straight line. Or if we observe something like this, sometimes we write like this: Z minus Z1 upon A Z bar plus A bar Z plus B is equal to K. In this case, K into 2A is equal to 1, then parabola greater than 1, then hyperbola less than 1, ellipse is equal to 0, circle. Okay, so these are the list, and we can quickly solve some of the problems. Let's say Z plus 4 minus Z minus 3i is equal to 5. So clearly this appears to be similar to the hyperbola. So wherever we have a mod of Z minus Z1 minus mod of mod Z2, then they may represent hyperbola or the ray. Okay. So let's see, depending on what is the value of Z. So Z1 is equal to minus 4, this minus 4. Z2 is equal to 3i. So what is Z1 minus Z2? That is minus 4 minus 3i. So this clearly represents a 5. Okay. So since Z minus Z1 is equal to K, that is 5. So obviously this represents a ray. So somewhere is, so how do we draw it? So this locus is, so minus 4 here, this is somewhere minus 4, and 3i is somewhere here. So this represents a So observe there, a wave, so the locus is a ray from 3i and this is from 4. Okay, so this represents a ray. Locus is a ray. Okay, let's take one more example. Z minus 2 minus 3i square plus z minus 5 minus 7i square is equal, let's say, 30. So what does this represent? So this is when square of modulus, we observe that when there is square of a modulus, this one, yeah, whenever the square of a modulus, that they represent circle, but the condition is that k should be greater than mod of z1 minus z2 whole square by 2. So let's see, what is z1 here? 2 plus 3i. Okay, what is z2 here? 5 plus 7i. Okay, so what is z1 minus z2? This is 2 minus 5, that is minus 3, and 3 minus 7 minus 4i, so that is something 5. Okay, so in this case, what is 30? So we observe that if z1 minus z2 whole square by 2 is 25 upon 2, na? And that clearly is less than 30. So what we observe, if you recall, so z1 minus z2 whole square less than k. So here clearly less than, so they represent a circle. And we know that if they represent circle, what is the center and the radius? So if they represent a circle, then we already done that they have a center z1 plus z2 by 2, that is 7 by 2 plus 10, 5i. So this is the center. So z1 plus z2 is the center. And what is the radius? Radius is 1 upon 2 2k minus z1 minus z2 whole square. That means half. What is 2k? K is given to be 30. So 60 minus 25. Okay, so clearly if this is the equation, we have to be cautious by this. So I already discussed that they represent a circle if, so this is the condition C, if they represent circle if 2k is greater than or equal to z1 minus z2 whole square by 2. That is sorry, yeah, that is the thing. So they represent a circle if 2k is greater than z1 minus z2 whole square.